Hi, my name's Daryl, and I'm a realist.
So I've had a few people asking me about the eclipse, and to be honest, I wasn't gonna get involved because it just seemed like everybody was covering it, and also seemed like it was kind of confusing, especially when you take into consideration the official explanation for the eclipse and how it's going to occur according to the trusted scientific community. So I'll go ahead and put in my 2 cents concerning the eclipse. So there's a lot of talk about eclipses lately due to the upcoming event of the August 21st solar eclipse. Now, this promises to be a momentous event because this will be the first full on total eclipse occurring solely in the United States in almost 100 years. Okay, so a solar eclipse occurs when the moon shadow falls somewhere on the Earth's surface. A lunar eclipse is the opposite. This happens when the Earth's shadow falls on the moon. The two dark sections of the shadow, the dark umbra and partially shaded penumbra's placement, determine which type of eclipse that we can see from the surface of the Earth. The basic mechanics of the Earth and Moon's rotation according to the heliocentric model goes as follows. We're told that the Earth makes a complete rotation from east to west every 24 hours. We're also told that the Moon completes an orbit around the Earth, also orbiting from east to west, every 28 days approximately, as seen here in this official NASA video. Since I like to keep things simple, I'll go ahead and give you a visual demonstration of this movement.
Now, in this example, we'll be using a mounted flashlight as our source of the sun, as seen here. So that's going to simulate the sun at a distance shining onto the Earth. Now we have our globe Earth over here, and I'll demonstrate how the eclipses work. But first, what we're told is that the Earth is spinning east to west, and sun's 93 million miles away like that. So what happens is, that's why we say the sun rises in the east, sets in the west. So in the United States, what we see on the east coast, sun hits here first throughout the day, spins, sun is over there, we continue to see the sun, and then it's nighttime. That's how it works, right? That's what we're told according to the heliocentric model. Now, the Earth completes a rotation every 24 hours, approximately. Now, as far as the moon goes, according to the official NASA video that we were just shown, the moon also orbits around the Earth approximately every 28 days, also in an eastward motion, as we saw. Earth was spinning this way, the moon was spinning that way. We just saw that from NASA's official video. So, both of these are spinning in an eastward direction. Now, solar eclipse, the way that happens is, let's say, for instance, because of the axis tilt of this particular globe, when the moon is exactly between the Earth and the sun, whoever is here in this region of Africa can see a complete and total eclipse of the sun, because the moon's blocking it out. Whereas on the other side of the Earth, in the instance of a lunar eclipse, the Earth is blocking out the light from the sun, so the moon will appear as completely dark on the other side of the Earth, according to the heliocentric model of Earth is what we're told. So, the moon also rotating eastward, the Earth is rotating eastward, and that's what we're told, right?
During the total solar eclipse taking place on August 21st, a strange occurrence is going to take place. During this particular eclipse, the shadow of the moon will be traveling from the west coast to the east coast. In a short video, and I'll post this link below in the description, the question was posed to the Washington Post as to why. Many people are asking the question, why the shadow is going to be moving from the west to the east coast. A lady by the name of Sarah from the science department of the Washington Post is supposed to be answering for science. However, once you take a closer, more critical look at some of the answers that were given, you will see exactly how convoluted these questions are. A little confusing as to the explanations that were given. Sarah herself had to go ask some of her colleagues for clarity. During this time of inquiry, Sarah asked a slim guy with a nice head of hair who gave her absolutely nothing. She also asked a lady who seemed to mean well, but also came up a little short. When her colleagues couldn't give her a straight answer, she had to turn to the experts at NASA. While Sarah sat down with NASA, a guy named Alex, who strongly resembles the musician Moby, he replied with a quote, saying, "To try to make it as simple as possible, it really boils down to how fast the Earth is spinning and how fast the Moon is orbiting around it. The Moon is orbiting about twice as fast as the Earth is spinning. So if we're looking down on the Earth and we're at the Moon, we see the Earth spinning, but the Moon is moving faster, so the shadow is moving across the Earth this way, which is west to east." End quote. Well, wait a minute. What it sounds like to me is that this guy's trying to manipulate the data. Now, also according to the heliocentric model, yes, it's true that the Moon does orbit around the Sun, somewhere around the speed of 2,288 miles per hour. But the distance of the Moon, according to the heliocentric model, is said to be right around 238,000 miles away from the Earth. Okay? Also, let's remember that the Moon only orbits around the Earth once every 28 days. Now, let me show you again in this example demonstration. I'll show you how this works according to the heliocentric model as far as the eclipse and his explanation that he just gave in this interview. But I'll also be showing an example of how it doesn't work according to the numbers that have been given to us by the official scientific community.
The way that Alex explained how the eclipse can work, yeah, that could work if we're going to manipulate the numbers as he attempted to do. You see, if the Moon is this close to the Earth and rotating this way, yeah, it could work that the shadow could, in actuality, come from west to the east coast if it's rotating eastward at the same rate of speed as the Earth, almost. But that doesn't work. See, we'll show you again. All right, one more time. That's the United States, and the shadow is coming from west to east. That's the Earth spinning around the same time. But what we're also told by the scientific community is that the Moon is at a much greater distance. The Moon is supposed to be 238,000 miles away. And we're also told that the Moon orbits around the Earth once every 28 days approximately. So it shouldn't be traveling at the same amount of speed looking parallel to the Earth, you see? That makes no sense on the heliocentric model, because that's not what we're told, right? We're told that 24 hours, the Moon moves this way. 24 hours, Moon's still moving. 24 hours, boom, boom. 28 days goes by, and the Moon gets right back to where it is. The Earth is spun 28 times for the Moon to get back to right here, is what we're told. Remember that. So when he tries to sit here and say, yep, that's why it happens, because light comes from this side to that side and it's spinning the same time. No, that's inaccurate. So let's move on.
My goodness, I watched this video, and at the end, Sarah even specified that we'll have answers for you in the following months. We have to wait months to get answers to our questions concerning this eclipse from these so-called experts. Now, me personally, I'd like to think that these experts at NASA would have answers readily available, also seeing as how they're collecting a nice taxpayer-funded allowance to the tune of around $52 million a day. However, we're not even afforded the respect from these trusted experts to provide us with clear, concise answers when we have real questions. Now look, I didn't want to go all flat earth in this video. I tried to play by the rules and use the data that we've been given from the scientific community, but since none of that seems to be making any sense, let's see how this works on the flat earth model. Quick breakdown. According to the flat earth model, or the azimuthal equidistant projection, it's widely accepted that the center of the map is the North Pole. Therefore, every direction away from true north is heading south. It is believed in the flat earth community that the sun and moon are both small and local as opposed to what we've been told concerning the heliocentric model. That means that the sun is not 400 times the size of the earth, nor is it 93 million miles away. Also, the moon is not 4 times smaller than the size of the earth, nor is it 238,000 miles away. The sun and moon make a clockwise circuit around the face of the flat earth. The sun moves slightly faster than the moon. Seeing as how the sun moves faster than the moon in this continuing circuit, every now and then the sun will overtake the moon and bypass it in the air and cast a shadow over sections on the face of the earth. This temporary overlap causes what we know as an eclipse. Given that data, let me show you how this works on the flat earth model.
Now, on the flat earth map, the way that we understand it is that the sun and the moon make a clockwise circuit. So there's the sun making its circuit. Now we add the moon in, and because the sun moves faster than the moon, there come times where the sun will somewhat lap the moon in this crossover. So this is kind of a sped up rendition of how this goes. Now, because the sun and moon are small and close, what happens here's what's going to happen, or what will work according to the eclipse. It's like the sun overlaps the moon there, and you see the shadow go from east to west as the sun overtakes the moon. Okay, because the sun moves faster than the moon, right? So once again, we'll call this 28 days. Go around, and we'll slow it down one more time. The shadow comes up on the west coast. The sun overtakes the moon. The shadow covers the United States from west to east. Just that way. And one more time. Shadow approaches from this side, clockwise circuit, and the shadow goes across the United States that way. And that's how that eclipse on August 21st can work on the flat earth map.
And that was my example of how the eclipse on August 21st could work on the flat earth model. So, Bill, Neil, Mick, if any of you have a better explanation than Alex pertaining to how this particular eclipse could work on the globe model, you might want to go ahead and bring it out. Allow me to reintroduce myself.
Hi, my name is Daryl, and I'm a realist. Also known as a flat earther. Checkmate.
From the surface of the earth. The basic mechanics of the earth and moon's rotation according to the heliocentric model goes as follows. We're told that the earth makes a complete rotation from east to west every 24 hours. We're also told that the moon completes an orbit around the earth, also orbiting from east to west every 28 days approximately, as seen here in this official NASA video. Since I like to keep things simple, I'll go ahead and give you a visual demonstration of the August 21st solar eclipse. Now this promises to be a momentous event because this will be the first full-on total eclipse occurring solely in the United States in almost 100 years. Okay, so a solar eclipse occurs when the moon's shadow falls somewhere on the Earth's surface. A lunar eclipse is the opposite. This happens when the Earth's shadow falls on the moon. The two dark sections of the shadow, the dark umbra and partially shaded penumbra's placement, determine which type of eclipse that we can see.
Hi, my name is Daryl, and I'm a realist.
So I've had a few people asking me about the clip of this movement.
Now, in this example, we'll be using a mounted flashlight as our source of the sun, as seen here. So that's going to simulate the sun at a distance shining onto the earth. Now we have our globe earth over here, and I'll demonstrate how the eclipses work. But first, what we're told is that the earth is spinning east to west, and sun's 93 million miles.
And to be honest, I wasn't gonna get involved because it just seemed like everybody was covering it, and also seemed like it was kind of confusing, especially when you take into consideration the official explanation for the eclipse and how it's going to occur according to the trusted scientific community. So I'll go ahead and put in my 2 cents concerning the eclipse. So there's a lot of talk about eclipses lately due to the upcoming event of